name is Tiao Singh. I'm based in Kuala Lumpur. I'm currently heading the strategic network evolution team across Southeast Asia, Australia, and also India. Right. So happy to be here to talk about intelligent RAN. Right. I think this topic is we have a lot of experts here. Right. So if you go to every booth, everyone is talking about AI. Right. And it has been talking for the past many years. So before the panel, probably give a bit of insights on, from my perspective, how the AI will actually impact the society. Right? So AI is not something very new. We have been using ChatGPT. I actually rely quite heavily on ChatGPT nowadays, right? But as a CSP, as an industry, do we actually make more money from ChatGPT? Do we actually see much impact on traffic in the network? Probably not, right? Then what's the deal on this sort of Gen AI, right? Ericsson actually have a mobility report study that the game changer will actually come when the AI agent come into the device. Either it will be on the smartphone or it will be on the AR glasses, right? You'll see actually Meta actually work with Ray-Ban, right? They have an AI on the glasses. When you tap on the Ray-Ban, you ask, hey, AI, what do I see? Right? You look at Taj Mahal, they will quickly do the inference and say, this is Taj Mahal. But this is probably still a fun thing to do, right? But a few years down the road, there are some research saying that if you use the AR glasses, you look at the car bonnet when your car is actually broke down, and hey Meta, what is my problem on my car? It gives you a solution. This is where it will start to add a lot of values to the consumer, right? So when come to the AI for the CSP, I see it as two parts. Number one is the whole world is talking about Gen AI. We play a role to build a high-performing network, reliable network to support the Gen AI application. This is number one, right? Number two perspective, of course, using the AI to build, not overbuild the network, but create a differentiated connectivity to support this our service, and also build a best TCO network for us to evolve further, right? This is the two perspectives that we have to work on, right? That's why in my slides, first, the demand is for the superior user experience that come with, that's generated by requested by Gen AI, and build a reliable and secure business. Of course, today we have the network deliver very reliable service, right? Moving forward, we actually enable the whole society to accelerate the society towards the digitalization. Right? Then, of course, very close to our heart as a CSP and industry, how do we actually monetize and keep our TCO low, right? With Gen AI, for example, with these Meta glasses, we do a study. It requires a 2 to 3 megabit per second on uplink. It's such a high requirement to build a network, but hopefully with AI, with automated, for example, resource partitioning, we are able to contain and deliver the user experience by not overbuilding the network, right? That's why you see all the use cases is coming up. There's a new business opportunity. We hopefully to have the AI to not overbuild the network, but deliver the SLA with certain intelligence. Of course, on the red line, we want to keep the cost down, right? Today, we do a lot of automation. We have cloud, but what more actually to reduce the TCO network? Now we have very good network, 5G, 1 gigabit per second, more than one. Do we actually need 1 gigabit per second? Let's say I stand in front of the base station, right? Probably I only need 50 to 100 megabit per second. So hopefully with this intent, I want to provide good user experience, at the same time, reduce my power consumption in my network. The intent is to cover both. But if you were to automatically, manually go and configure this, it is not possible. That's why automation with AI will help to balance up. We deliver the intent to have good user experience with TCO and with less mistake AI and automation will help in this journey. Some of the thing is already in the market today. For example, AI will help to improve the capacity in the network. If we do something in the link adaptation to improve and remove the bottleneck, for example, better predict the users moving from different radio environment, it will help to improve the spectral efficiency. The latest study from Ericsson with a trial, we actually see by having AI in link adaptation, you improve the spectral efficiency by 10%, just with some algorithm, with some intelligence. All right? You can imagine how much money we need to spend in order to improve a 10% of the spectral efficiency. Right? For example, cell shaping. Right? For some coverage which is not so well covered, because the way we design the site, if we have AI to analyze in certain time of the day, we shift the cell to cover a little bit more in this direction, it will improve the further user experience. All right? Mobility and anomalies detection. There are some faults in the network that we typically not able to detect. With AI, it will help to detect. Right? So, at the end, we have to sort of do a step back, right? What do we actually AI bring to CSP? We want to make money. We want to sort of go into the new paradigm with differentiated connectivity. AI will actually help us not to overbuild the network, but deliver the SLA. When more and more service come into the picture, we move into the new operation paradigm, which we want an autonomous network, and AI is the key ingredients. Right? If you go back into the fundamental, we really need advanced silicon to deliver best experience. We have cloud, hopefully to reduce the cost. AI is the key fundamental, but vendors like Ericsson, we don't do AI all over the world. It has to have the open interface so that the AI can be embraced with all the industry, the intelligence incorporate into the RAN to make the best out of it. Right? Then back to the questions. Where AI should sit. Right? We have our sort of design philosophy. We should implement the AI where it matters. Right? Of course, everyone wants to build the AI algorithm into the baseband or the RAN compute. Right? But if all the intelligence sits on RAN compute, then every operators need to upgrade the baseband hardware every 3 months to 6 months. It will not sustain. All right? So we are thinking of if those decision or requirement need to be made within millisecond or microsecond, it has to be very close to the site. It has to be processed, and the inference has to be done on the RAN compute. If those intelligence is non-real time, analyze where the traffic are, it has to be sit somewhere else, right? A centralized server. In this case, we say the AI should actually sit on the server, or in the Open RAN concept is the service and orchestration level. This sitting on this level also is good. Not only the vendors can have the software to contribute to the whole industry, but CSP, you have your own software, and the third-party software also have some AI sort of intelligence. It can be incorporated in that layer and influence the RAN. Of course, Ericsson is making sure we make sure our baseband, when all the AI's features coming in the next few years, it will not burst the hardware, not burst the capacity of hardware. We make sure that all the capability within the chipset today, we call it the massively parallel processing with MCAR, right? With the multi-core technology we have, the AI with the features will not impact the baseband. Like I mentioned, right? Some of the intelligence, you need microsecond, millisecond, it has to be sit on the RAN, right? The rest, it has to sit on the RFs, which is more on the service and orchestration level, right? So eventually, we will see the trend is going in this direction. Last year in MWC, they formed an AI's alliance, right? So there are 3 architectures being discussed, right? For those intelligence really has to sit on the baseband. We call it distributed AI in RAN. You improve the radio performance. It will impact thousands of sites, right? Where some of the intelligence, which is non-real time, it should sit on the RAPs or more inference on the SMO, service and management orchestration level. It has to be centralized, right? Then they give a bit of good mix, right? For those which require a real-time processing, the latency is critical. Sit something in between, which is AI on the RAN, which are on the edge, right? To deal with some time-sensitive application, right? So overall, AI has been a talk in the town for, for some time, right? But what we feel as an industry, number one thing we need to do, build a good network to deliver differentiated connectivity, at least to support the Gen AI application today, all right? Secondly, build a high-performing network with intent, with the help of AI to balance out the best performance and also the best TCO to help the operator improving the top line and also the bottom line, right? Then this is the foundation to accelerate when we actually move to 6G. Ericsson is actually leading some of the research to contribute in this direction. I hope I share something useful today. Thank you very much.
I would like to invite Sanjay Thakur, Senior VP Network Planning and Engineering, Reliance Jio. Please welcome Mr. Nirmesh Yadav, GM Network, Bharti Airtel. Rajesh Singh, EVP Technology, V. Mike Meluzzi, GM Radio Access Network Division, Next, Intel Corp. Dr. Venkat Virarvagwan, Product Owner, Wireless Network Solution, TCS. Ratnakar Rao, VP Communication R&D, Samsung. And at last, I would like to welcome the moderator of this panel, KG Purushothaman, Partner and Head of Technology Transformation, KPMG, India.
Good afternoon, everyone, and thank you, Smriti. I want to first thank you. What a context that you've actually set for us, a fantastic background to the topic itself. I just want to take all of us 3 years back, and the evolution of this topic itself in the India Mobile Congress. So when I was brainstorming with our esteemed panelists, we actually spoke about, how this topic itself from an Indian context has evolved. From 4 years back, we started talking about 5G and its rollout. We started talking about how brownfield versus greenfield implementations are getting rolled out in India. We also spoke about last year about Gen AI and AI actually transforming the landscape and its interoperability with the multi-vendor ecosystem that we have in India. And today, we are actually going to cover a very important topic of intelligence that itself that has got built within the ecosystem, and how our organizations not only innovating but also helping telecom operators to transform. And that's the whole context with which we have actually been covering this topic. And we have a very esteemed panelist here. But to, just to get some value out of the entire session, I've actually tried to divide this topic into 3 parts. One is on the topic itself, the innovation. Okay, when it comes to innovation, what exactly is happening in the space of intelligent RAN? The second, I want to cover what kind of value are operators expecting to derive from it. And the third is we'll then go to the operators to try and understand what is the innovation that they are bringing in by adopting this. So these are the 3 ways in which I will like to divide the topic. So Mike, if I could come to you first, and then to Ratnakar also. When it comes to innovation in the field of intelligent RAN, the innovation that you're doing on rolling out the silicon chips and the rollout of the technology itself, what are the new things that we are actually seeing? How are you developing the ecosystem itself that is continuously evolving in this space, and how can companies start benefiting from it? Can you just cover the entire aspect of what kind of innovation is happening in intelligent RAN?
Yeah, from a silicon
Yeah.
perspective, right? So I'm working for Intel, right, driving our RAN business, from a standard product and custom perspective. But what's happening in the industry, right, in terms of what innovation is coming, right? So what you see is you have a demand for AI everywhere, like especially in the RAN, right? And what we see in talking to different service providers and partners and that sort of thing is like the RAN silicon has to be enabled for all the use cases, right? But we don't know what those use cases are, right? So, from an innovation perspective, what we're trying to do is to make sure that our platforms, our silicon, our products are AI ready and AI capable, right? And do that, in a very performant and efficient way, right? Because when we talk about RAN or we talk about telco, right, it matters that you do something. The TCO always matters, right? It can't be these pie in the sky use cases that like, oh, if you build it, they will come. No, with telco, right, reliability matters. Security matters, right? But overall power and TCO matters, right? So from a silicon perspective, what we are trying to do and drive is really, from a core product and platform perspective, build AI into the core platform from a core perspective, right? Build specialized instruction sets in there, and then with the development community, they can just go and access it, right? And what we've seen, and this is from a AI for RAN context, right, is the AI models for RAN to improve the performance and give you a very performant RAN. They're small parameter models, right? They work super well on cores, right? And having a platform that builds it in, like we're trying to do with Intel Xeon, it works very well for a lot of the vast majority of use cases, I would say.
And Mike, if I could just ask you a follow-on question. Innovation comes on the back of challenges, and challenges that you constantly discuss with your customers. How has the RAN architecture itself evolved to address some of these challenges?
Yeah, that's a good question. I mean, and I know there's a lot of competing RAN architectures out there, right? What I'm promoting from an Intel perspective is having an architecture that has ubiquitous support for AI capabilities. There are other architectures where, hey, you're going to accelerate a certain function or do a certain function in a custom way, right? That's a different approach, and there's obviously different competitors that will push out GPU solutions or high power GPU solutions that serve as sidecars, right? So I think that really I'll bring it back to telco economics and the ability to meet an overall TCO. You have to build something that meets the performance, meets the power, and meets the cost target, and you have to do it in a very efficient and flexible way.
Thanks. Ratnakar, if I could come to you. You focus a lot on research, and I think we also spoke about how you are actually covering a lot of research that is more futuristic, 6G ready, things like that. Taking a clue from what Mike said, challenges come at the forefront, and there are enough and more challenges when it comes to adoption. 5G adoption itself with interoperability, and now 6G as well on the advent. What are the kind of what is the outlook that you are seeing when it comes to RAN technologies and the intelligence that is getting built, and what can be expected by the operators and the representation that we have here from a future standpoint?
Yeah, thank you very much, Faru, for that question. So when we talk about intelligence in the networks, especially RAN, so there are some use cases which are given, which are functional today, already commercial today. Like for example, your network operations are largely being automated, network fault prediction, detection, management, right? So some of these things are given. And some of those things like say the TCO reduction, energy savings, optimization, all those things are getting commercialized as we speak. But now the question comes, okay, will AI get deployed piecemeal? Like, okay, this is the AI inside DU, this is inside RU, this is inside CU, or this is in your data center but not at the cell site, all those things. So what do we actually mean by a AI native, network or AI native RAN? So that's where I think the biggest challenge is, when we talk about all these Gen AI and large language models, we don't talk about hardware accelerated Gen AI. Gen AI runs on general purpose, compute, be it CPU,
start
GPU,
with.
or NPU, whatever it is, right? So the general purpose platforms themselves are getting powerful and powerful day by day. So for this network to become truly AI native, I mean, at least we at Samsung believe that the fully virtualized end-to-end network is the way to go, so that you can actually embed AI not only locally but end-to-end. So that's the direction in which we are taking it forward. And we have some great successes. Maybe like, for example, of course, all the energy saving and all are little higher layers. Like today, for example, the spectrum, the golden spectrum is the bread and butter of all the telecom industry. And we have learned a kind of better lesson with all the FR2 lessons. So now when we see how to extract the juice out of the existing golden spectrum. So we found that by applying AI for channel estimation, because channel is the most, really the only variable out there for a wireless communication network. By applying AI for channel estimation, you can actually squeeze out more out of the same spectrum and bring some 10 to 15% of the spectral efficiency out of that. And that's going to be a huge attraction for the telco partners. So this is the kind of deep AI what we are talking is in the works, which can actually lead to truly AI native networks.
So, so Ratnakar, I think both you and Mike actually spoke about how to make the most of it so that you can get the most effective TCO. Venkat, if I could come to you, because you do a lot of implementations and also you have a all-round understanding of not only India as a geography but also global. What has been your experience when it comes to seeing intelligent RAN being first adopted? Are there any learnings that you have seen that can be actually replicated by our telcos in India and also the implementation partners?
Yeah. So I work for this, whatever the PM said, right? The Swadeshi project. I work for that project. So we have implemented in his presentation, the lowest layer, SON is already there.
Right.
Some of the use cases you mentioned, like energy saving, the customer is chasing us. They really want it to be done. But in the context of what we're discussing, what's going to happen, all the AI that you can put inside the RAN, even though they are general purpose, I would assume they will still be limited to cell sites. There'll be a lot of AI that runs in the central data centers also. So I think one of the lessons we should learn, this is based on my interaction with some of our customers, is we need to collect enough data for the AI to be useful. Stitching data from multiple subsystems and putting them in one place and making it accessible to AI, I think that is what I would like to learn. I think we're currently doing it in silos. And with more and more AI coming, that line will become blurred. So get all the data in one place that AI can use if it's going to be centralized. If it's not centralized, be very careful about how much data you want to give.
So Venkat, we are talking about data, which is network data, customer data.
Yes, of course.
And you're talking about, the golden phenomenon, the golden asset that the telcos actually have. And I clearly agree with you that for AI to be effective, for RAN also to be effectively implemented, making some sense of the data is very important, and how you work with the operators to make that happen is really important. Let us trying to understand from the operator's perspective also now, how are they actually adopting it? Rajesh, if I could come to you, I think there's been enough spoken in this panel itself about TCO, optimization of the spectrum, efficiency, and also making data available for AI to actually work. This would be music to your ears, considering that you work with an ecosystem of partners. So, what are the practical challenges that you have seen, and how have you been able to, make some sense out of the entire puzzle? I'm sure that you have done a lot of innovation when it comes to adoption of RAN and also intelligent RAN. Can you can you help us all understand how is we trying to make this work?
Yeah, thank you, Purushottam, and I'm very happy to see this your panel title, the Intelligent RAN, because generally operator are always known as a dumb pipe, and first time I'm seeing becoming intelligent, so I'm really enlightened. And the RAN being is the biggest cost center in the wireless industry, so and is, as we say, all necessity is mother of invention. So I think it's going to be very fast AI adaptation in RAN side, because if you need to solve the TCO problem or productivity or experience, the maximum gain or low hanging fruits we can see is on the RAN side. So that's why it's a very relevant topic which need to be worked upon, because it's just evolving. It's not easy to, because so many things has to change. There's computing power, the RAN cell sites is low power budget, low computing power. There is a like panels teams who are discussing the centralized versus decentralization. So all this concept was there. We going to edge level. And finally, if you see the AI, how it works, it's between human, device, industry device, and the prompts in between, right? The tokens are exchanging between two models and all. All this fixed by the finally the connectivity layer. So to get best out of it, I think a lot of things has to change. And you asked basically on the what we're adopting and all. So I think as some panel member has said, data is very important. Where is the data? Where are all the data where you can make sense and you can implement? In that direction, at least there was a platform already in the telecom networks, which was the SON. So it is the collected RAN data, a lot of insight of customer KPIs, experience. So those were there. I think the first model started coming in that side. And that also was helping to optimize the network. So it's like self-healing networks or all other load balancing and all was happening. But it's becoming more intelligent. Now it's more intelligent, and we also has adopted already one AI model in the SON on the energy saving models. This is called intelligent dynamic energy saving. It's called IDES, one of the models which has been developed by one of the technology partner, and it's available in our booth. You can people can come and see. We are already showing one use cases on the AI SON, and largely in the concept of AI smart sustainability, because that's the first thing which we can be done easily. So that's one area started happening where more complex networks, more energy guzzling, more power consumption. So it was the first area where you can attack and you can improve the OPEX efficiency, you can bring faster, and as well as you can improve the experience of the customers, because you will almost real-time improvement you can have. But adaptation will be anywhere. That's on SON is fine because the platform was there. But once you move to RAN side, really the adaptation will be real. Some challenges it had already, because what you need to have more power, more computing, and you have to go to CPU or you have to go GPU. All those debates are happening, and it's economically there's a challenge if you can't deploy GPU on all the sites. So maybe a lot of things are architectural which was changing, the cloudifications, then edge computing, where something will be maybe centralized, something will be decentralized. In between, we'll find the paths to get the right computing powers, where we can have right economic scale and you can say the sweet spot. And then those adaptation will be happen early. And of course, as Ericsson was highlighting that something already then baseband, they started putting some more computing power. If that comes, then that has to be anywhere happen. And the spectrum efficiency, another area, which is something will come faster.
Thanks, Rajesh. Nirmesh, if I could come to you, when we were brainstorming and you specifically spoke about taking clue from what Rajesh has also said on the use cases for customers. You specifically also spoke about how you are transforming enterprise customers, your data centers, and many other enterprise use cases with with an intelligent RAN. So can you expand on what are those early adoption use cases that have been really successful? How have you been able to drive efficiency and sustainability when it comes to its adoption also?
Yeah. So automation has always been a focus area at Airtel, and it's been even since 4G days it has been a area that we were very keen on. But now with AI and ML basically coming in, it has taken a center stage, and now it has become an integral part of our RAN operations. So so from right from capex planning to all the way to opex optimization to user experience management, all aspects of RAN operations are now in some way basically controlled or are being touched by AI.
So embedding it into the customer journeys and the flow itself.
Yes. And so to give you an example where we are really seeing the benefits, that there are multiple use cases that we are working on. There are multiple ways we are integrating, and we are at different phases of in our journey of integrating and using RAN. But there are some cases where we have already seen the gains in terms. So to give you some examples, new site planning right now. So earlier, we used to do it manually. Now that whole process has been automated in Airtel. So there are AI algorithms which ingest data from network KPIs, traffic patterns, customer data, and then we are able to predict which site we should deploy for which will be able to give us ROI, and which sites probably if you deploy, probably there will not be enough revenue from that site. So that decision is automated. From spectral efficiency perspective, again, AI is playing very important role. And I can give you an example of a problem which was basically has been there since 4G days, and there has not been any a good solution to us available to us in 4G network. But when 5G came, there are a lot of intelligent hooks which were built into 5G, which were able to solve that problem, which was not solved adequately into 4G. So basically, there's a tropospheric ducting issue in the network which creates interference, and the nature of the problem is that it's very random, and you can't solve it manually or even any rule-based automation. But now we have some intelligence in the in 5G networks, and using those features and integrating AI ML based techniques and exploiting those hooks. Now, real-time network we are able to predict and map. It's a complex problem. Basically, there are multiple interfering sources, cell sets in the network, impacting multiple victim base stations. So it's only by using AI that we can tackle and solve this problem. And now we have those. So in 4G days, what we had some SON solutions. They were intelligent, but they were not good enough. But it's now that we have 5G, and then those intelligent hooks are there, and we have this capability to integrate those RAPs and orchestration layer, which is able to exploit that we are able to solve that problem. And then basically also we have this, in fact, all the SON features that were there, which were providing some sort of automation earlier, those have been, have moved to the next level by the help of integration of AI, and we are in the process of building them in our network.
Sure. Thanks, Inmesh. Sanjay, if I could come to you, I think George spoke about new business paradigm. I know that I'm taking that clue from what you have said, and we spoke and we brainstormed about the new business models that you all are also coming up with, and the operators also coming up with when it comes to taking advantage of intelligent RAN and making it a better user experience for the customer, better monetization models for the operators. Can you give us some examples on how entire intelligent RAN is converting into a complete paradigm shift when it comes to a new operating model that is getting evolved, and how is that benefiting both the operators and the customers?
So let me speak about Geo Network, for example.
Sanjay, could you speak closer to the mic?
Yeah. Can you hear me now? Yeah, okay. So Geo Network today carries the highest traffic in the world. And to carry such an amount of traffic, we need intelligent RAN as a clear-cut strategy from our side. So we are working on intelligent RAN for many years now. We see that the intelligent RAN will fully come into shape in 6G. There is no doubt about that. But the foundation of that has to be built now. So the foundation for intelligent RAN is already started. The next 5 years, intelligent RAN foundation gets built. The same foundation then carries forward to 6G. And we all know that in 6G, the overarching principle is ubiquitous intelligence, and the second use case is AI in communication. Now, how we see AI and intelligent RAN taking shape in various factors and various forms. The first is, from a reactive model, we go to a predictive model now. Currently, most of the operations, most of the planning is more reactive. Now we go to a predictive model. We are able to predict. We are able to predict the traffic. We are able to predict the interference. We are able to predict the demand. We are able to predict the congestion and also predict the coverage. So from a reactive model, we go to a predictive model. Is the first change that we see that is happening now. Then second is in terms of performance. Performance, scaling of the performance, as we saw in Thiau's presentation, scaling of the performance in terms of throughput, in terms of latency, in terms of energy efficiency, and so on and so forth. The third major point we see is improvement of the overall efficiency of the network. In the terms of spectral efficiency we discussed, in terms of energy efficiency, how we can take energy efficiency to a new level. And the fourth point will be agility, how fast we can adapt. For example, Mahakumbh. We had Mahakumbh in very recent times in India. And crores of people went to Mahakumbh. And one of the use cases we implemented in Mahakumbh was mission critical. So mission critical customers, we can have a separate slice, as you just asked, one of the monetization or the use cases of intelligent RAN is network slicing. So the main focus today, as we see, is happening on 5 different fields. One is energy saving. Then we have mobility optimization. Then we have load balancing. Then CCO is coming up in a new shape. That is capacity and coverage optimization. And the next will be slicing. Now network slicing has already taken shape in 5G. And it's one of the critical factors in terms of giving customer experience for enterprise customers, for private 5G customers. Let me give an example of AMRs and AGVs, automated mobile robots and automated guided vehicles. Now, AMRs and AGVs are running on a particular slice, and that slice has a different QoS. And that QoS, enterprise customers demand a separate QoS as per their use case. So the definition of the slice, the resource allocation of the slice, the quality of service parameters for the slice are all critical factors that have already taken shape and now are going to build further and further. So mission critical is one example, enterprise is another example, private 5G is another example, low latency and gaming. Another aspect of slicing is also taking shape in the terms of URSP now. UE route selection policy, now the device operating system already started, Apple already started supporting URSP. Now URSP can be done only in SA network. And using URSP, the traffic of a particular application can go to a particular slice. And that slice can have a different QoS parameters. For example, if I have a Teams call, I have a Google Meet call, that traffic can go to a particular slice, and that slice can have separate QoS for this particular use case. Another use case could be gaming, a gaming app. Now the app, based on the app, I am deciding the slice. We can decide the slice based on a UDM definition. We can decide the slice based on HSS definition. We can decide the slice based on destination IP. We can, and there are many other ways of allocating a slice. But the optimum use case, as we see it growing further, is one based on UDM and HSS profiles, and the second based on URSP. That is our.
Fantastic. Thanks, Sanjay. I think we heard the
the innovation that is coming up in the intelligence space. We also spoke about adoption. We just have enough time to take one question each. I just want to go around, ask each of you one challenge and one recommendation that you would give for better adoption and faster adoption, so that 1 year down the line, when we talk about intelligent RAN again, it is intelligent RAN on a well adopted AI integrated framework. To make that happen and more use cases to come in, what is it that needs to get done? Venkat, if I can start with you.
Can't think of anything straight away. I think I would go back to what I said about data.
Yes.
So we
critical.
must invest in getting the data available
Yes.
for AI to work.
Right.
That's what I would say.
Fantastic. Ratnakar, if I could come to you.
Yeah, just I'll also touch upon previously what I mentioned, that virtualization is the way end-to-end software for an AI native network. See, as a vendor, actually, you can do all kinds of AI because all our operators are having diverse needs.
Absolutely.
Some may be TRAN customers, some may be ORAN compliant solutions. So we do all kinds of solutions, right? But what is the way forward, right? So the way forward, why again I stress upon this VRAN as the way is, it offers all these three benefits by moving to this powerful COTS platforms, CapEx savings, applying AI, OpEx savings, and then by sharing your compute with other AI applications, you can do monetization also. I mean, it's like a
Perfect.
all three solutions solved with one hit, right? One shot.
Thank you. So data, VRAN, Mike.
Yeah, I'll go back to a comment I made about, when, in terms of recommendations, focusing on telco and looking at, the overall TCO, right? You have to do things that make sense from an overall business case perspective, right? I certainly share your love for, virtualized networks and open software development.
Mike is so happy to hear that.
Yeah.
Thank you.
But TCO matters,
Yes.
right?
Thank you. Sanjay?
So AI basically taking shape in three forms. One is AI for RAN, and that means I am doing processing outside the baseband, doing the learning, the model is learning outside, and I implement it into the baseband like a non-real-time brick. That non-real-time brick is going to take shape first.
Right.
Near real-time brick is a slight bit of challenge because of the timing requirements. The second will be native AI inside the baseband. So the native AI inside the baseband obviously will need capacity, the processing capacity. The third we see is AI on RAN. That means I have a GPU which is co-located with my baseband, and some of the processing is done by the GPU, and it transfers the learning to the baseband accordingly. So these are the three steps. I think the things are evolving and the things will go further.
Perfect. Thank you. Ramesh?
So, from our perspective, for AI, one of the challenges that we see, and one of the factor which will be critical for the faster adoption of AI will be basically making sure that we have open and interoperable interfaces available in the RAN. Because right now, intelligence is being built into the systems, and the standards are basically giving the hooks. But we still see that there is, the adoption of those open interfaces still lacking from the ecosystem. So that's one key challenge that we see and that needs to be worked on to unleash the true potential of AI. And one additional thing that we believe is that going forward into 6G system, we must make sure that whatever investment that operators and ecosystem partners are making in the 5G and 5G advanced stages, and basically generating data sets and creating algorithms and techniques, those are leveraged, and any 6G related changes are built on top of that. So it should not completely change the framework and all that time and effort that we spend on hardening the AI framework, that should not go wasted.
Very interesting. I have a panel exactly on this topic tomorrow. Thank you. Rajesh?
Yeah, so I think what Sanjay was saying, I will little bit, because there's three layer we talked about, AI Alliance already talking, AI for RAN, AI and RAN, AI and RAN. So that's very clearly discussion is happening. But I think we have to adopt right architecture because there's a long-term goals. The three stages we're talking about, it might be next 1 decade. we go in that one. The problem of right now AI is device, network, hyperscaler, it's in connectivity in between, right? So all these four are involved. So its right integration has to happen. And LLM models are established, device are AI already getting enabled because device people are independent. They're not seeing what network people are doing. They're just doing the AI, they're selling their devices, AI enabled. But what you do AI enabled devices, unless certain networks and somebody is hyperscaler is giving you token response. I was talking the token earlier, so there may be what we're talking now user throughput, we'll start talking token throughputs. Very soon that will happen. Uh, so right architecture is very important. Some researchers are feeling, there will be LLM and there will be SLMs as well. So there's a right balance between large scalers, hyperscaler data centers, then aggregators for the edge computing, which edge was not happening, but edge might come. So some SLM will be in between our device. So SLM, LLM, this mixed combination architecture, if people able to balance it out, then it will quick adaptation will happen. Otherwise, this hyperscaler in between devices, if network we can remain again in dump, it might will remain a challenge. So I think the right architecture adaptation has to be these alliances with people working. I think this discussion is happening. It has to be between split between LLM and SLM. So right balancing can be done and right adaptation can happen. And quick adaptation can happen.
Getting it right the first time is also critical. But thank you very much. Fantastic session. I'm sure all of you all have benefited from this discussion. We spoke about not only innovation. Thanks to you to set the right context also. It gave us a lot of leads into what we've discussed: innovation, adoption, and also challenges that could be addressed through a lot of recommendations that our panelists have given. Thank you very much.